Hello all, welcome to this lecture where we are going to talk about Transformer. Transformer plays a key role in generative AI and its understanding will help you understand why generative AI is so popular. Let's start with understanding what is Transformer. So Transformer is something which was introduced in 2017 in a paper called Attention is All You Need, and this was done by Google's DeepMind. It formed the core architecture of generative AI. Transformers excel in tasks that mimic human content generation by building contextual relationships, which was not possible earlier. And this was made possible because of self-attention mechanism. What is that? Let's understand it. It's a key innovation allowing the model to focus on relevant parts of the input when generating output tokens. And what's the functionality? It considers the importance of each input element, enabling understanding of long-term dependencies. And because of this, transformer-based models have outperformed previous architectures like RNN and CNN on translation and natural language tasks. Okay, so let's understand this self-attention mechanism and this architecture in more detail. For that, we'll go to a website and see how transformer behaves. So this is the website I was talking about, where we can see the internals of transformer. So firstly, you can put an example, you can put a statement and try to see how the next word is calculated. And one of the existing examples I have selected from here, there's a drop down. You can select an example or you can put one example on your own. So what I have selected is data visualization empowers user to. So what should be the next keyword? How it is calculated in transformer. Okay, so firstly, this is the input. So here you can see data visualization empowers users to. Okay, so these are tokens, not words. So data is one token, visualization is one token, M is one token, and powers is another token. So empowers have been broken down into two different tokens. And these tokens have a token ID. Okay. And then these tokens are given a positional encoding. So data starts from 0th position, visualization 1. And this positional encoding gets added to token embedding. And then a final embedding is created. Okay. Here this website uses GPT-2. And there it is using 768 matrix vector. So that's why it is 768. Okay. So that's how embeddings are created for the input in transformer first. And once it is created, a QKV calculation is performed. You can see the calculation is being performed over here for each of the keyword: data, visualization, empower, tokens, users to. So these are tokens, and these embeddings will be multiplied by QKV weights, and then a bias will be added, and then a final QKV multiplication will be given here, and this is how it is done. Okay. And how this is done over here, let's see that. Okay, this is the heart of the system, which is the attention mechanism. So how does attention mechanism work? So if you see each of these token, data visualization empowers user to, these are keys and these are queries. Okay, and there's a dot product matrix created using these. If I select any of them, for example, I select this, so it is doing dot product of visualization from query and from key, both visualization word. But if I select this one, here it is doing dot product of powers in key and visualization in query. So that's how a dot product is created, and it has a range, and then that dot product is masked and scaling is performed, and finally a softmax is created, which gives us the probability. Okay, so that's how a self attention mechanism is created, where each and every token is considered and its mapping with the each and every token is considered while calculating the next keyword or token. Okay, and this self-attention mechanism along with the value, which is again these, is given to this particular block. Okay, and over here we can see only one head. It is multi-head self-attention, so there are 12 heads. Okay, we can visualize only one, but underneath you can see there are multiple heads, so there are 12 heads, and then a vector is created for each of these words and then fed into this block. And over here as well, and then one more transformation is performed. And if you see this 768 vector is then becomes 3072, which is multiplied by 4. And then one more transformation is applied, and then again it becomes a 768 vector. And based on this, probability scores are generated for all these words. You can see here for visualization, for the next word to be visualized, it is probability softmax is 35%. For create, it is 13%. Similarly, all these things. Okay, so that's how transformer works. It takes all these inputs end to end, and then it creates probabilities. And you can control the temperature over here. Currently it is 0.8. If I reduce it, which we have seen and discussed, the lower the temperature, the higher the probability of getting the right result. So when I make it to 0.02, visualize becomes 97.64 and the next word becomes visualize. And if I increase the temperature to more than 1, so all these probabilities reduces and it can randomly select any of these words which may or may not be correct. Okay. So that's why temperature plays a key role over here. Okay. So these are the internals of transformer. I hope this has helped you understand the transformer architecture. Let's go back to our slides to understand rest of the things in transformer. Now let's see what are the mechanics of self-attention. First is position embedding. So it encodes each token's position within the sequence to distinguish between identical tokens. So in the example that we saw earlier, we had these words, data visualization empowers users to. What if the word empowers repeats or users repeat? So over here in transformer, it adds position as well, which we saw at the initial stage. Position was also added to the embedding and a new embedding was created. So that's positional embedding is also considered in the final embedding. That's what we are trying to explain here. And the next thing is query, key and value vectors. So each token is assigned a query, key and value vectors, and self-attention weights these values based on relevance. And how it is done? It computes dot products between these vectors, which we saw how it is calculated, and creating attention scores to assign weights. And then result, tokens are represented as weighted sums capturing complex input relationships. So all these complex input relationships are being considered and then a weighted sum is generated. Let's discuss more on transformer architecture. If you have explored transformer architecture earlier or you have read some documentation about transformer architecture, you would have seen this diagram. And this diagram looks very complex. If you look closer in this diagram, it has input and output. We saw that. It has positional encoding. We saw that as well. And it has multi-head attention. If you see the orange boxes, it says multi-head attention and we see all of that. And we have also seen Softmax, which is the output probabilities, how it is generated. So all of these architecture details we saw and we tried it as well. So that's pretty much in transformer. I'll share you the link of this website. You can try it out yourself and understand transformer more. I hope this was easy for you to understand what is transformer and how it behaves. Thank you. See you in the next one. Bye.